Hi guys, this will be a quick overview of the top-level block diagram of the QuickStack Hello. To start off with, in brown, we have all the external connections. That includes one USB connection for FTDI interface, one USB connection to connect to the debugger, a in-circuit serial programmer, two switches, and the QuickStack interconnect headers. So, some of the large blocks internally are, of course, the debugger, which you can program through the USB here. So all you have to do is connect your USB that connects to your debugger, and then via the integrated development environment, you can program the main processor, which is in this case a PIC24FJ128GA310. The MCU then has a number of things that it connects to. It has a temperature sensor, so you can use the board for temperature logging and so on and so forth. It has an EEPROM where it gets some. You can pretty much store anything. It stores the serial number of the device, as well as, very importantly, the voltage reference offset. Now, what that is I forgot to draw it in here. Here we have a 2.5 volt reference that comes out of the power regulation block. The 2.5 volt reference is a 20 ppm reference, but the actual accuracy is about 3%. So it's not that accurate, but that accuracy you can calibrate out, and we do calibrate out with a 6.5 digit multimeter. So we store then the actual calibrated value in the EEPROM, and the QuickStack software then uses that offset to calculate the actual analog values that you might be measuring over either the two smart lanes or the main lane. So, furthermore, the FTDI chip has a parallel interface. The parallel interface is, realistically, you can get about 1 megabyte per second. Now, obviously, in PC terms, that's not very fast, but considering this is a 16 megahertz, 16-bit processor, it is incredibly fast for the embedded world. If you see the data coming in through a serial line at 1 megabyte per second, it's impressive. Okay, furthermore, we have the red LED and the green LED, just something to get your first Blinky program going. Very, very nice to have. You'll notice that here I drew a whole bunch of little purple boxes. What we actually do is, from the MCU, we have on every single line that goes through the QuickStack header, we have a small filter on there. What this does, it just takes the edge off of the signal. So instead of then seeing on your facility, it reduces ringing. So instead of getting a signal something like this, we actually measure our signal, even when we just use the long scope probes, as just that. It is incredibly, it really helps the signal integrity and prevents crosstalk between the lines. The 5 volt line output, it has a current limit on it. That current limit is set at around 1.5 amps. So as soon as you go over 1.5 amps, which is really the maximum that the board is rated for in traces and so on and so forth, when you go over 1.5 amps, a current source kicks in. So it just sources 1.5 amps until that particular chipset, the current source, gets to its thermal limit, and then it shuts down safely. This means that you can put a short straight across the 5 volt to the ground, and the board will shut off because there's obviously a lot of current going there, but it will not damage anything. The same goes for the 3.5 volt. And the 2.5 volt reference just has an op amp on it, and it's not expected that you're going to actually draw load off of it, so it does not have that. Loads of ferrite beads sprinkled all over the power regulation. Again, it's to keep the high frequency noise out and just makes everything a little bit better for the power. Lastly, this particular processor has 2 smart lanes, A and B, each of 6 lines. So you can have 2 smart lane boards. Then you still have this 16 channel main lane. We have an I2C bus on the shared lane, as well as the QuickStack bus on the shared lane. Lastly, we have the debug interface. What this is a series of analog switches that allow us to set how we're going to program the MCU. So we can either program via USB through our debugger in straight this direction, and in that case, this is the default setting. This is how all the boards are shipped. This interface is connected like that. The other way you can do it is we can actually, sometimes if you want to have a more powerful debugger or with a little bit more features, you can still connect an external debugger. These ones might include a Realize, for example. Realize can do so much more than this, although for most applications you can get by with the onboard debugger quite well. It's way more powerful than doing printf statements or something like that. So the other way you can use it then is to connect that debugger to the external link, and then you can program this way. There's a small solder jumper on the back of the board, on the back of the Hello, which is used to set that. Then lastly, what we can also do is we can actually use the debugger to program other boards. This can be any other board, so any other board that uses a microchip processor. So it essentially acts like a PIC kit. The only difference is that the PIC kit has a lot of internal memory and one-click programming, which means that you can hook it up to an application and you don't need to have a PC attached. But again, if you're debugging, you're using it, you can use this very nicely. So what this can also do is we can also make a connection in this direction. So then we have it connected like this. That lets you program, for example, worker boards. They don't need to be programmed, but if you want to put them in a low power mode, we have to reflash a chip on that board. That can be very easily be done. We just stack a worker board on top of the brain board. It auto detects because the worker board has a 3 volt, I think it's this pin, don't quote me on it, this might be wrong, 3 volt, 3 pin here on the worker board that is actually shorted to this last pin, which is kind of like an ID pin, so we can immediately switch this over automatically as soon as you put a worker board on top and set it for programming. Anyways, that can be used, so it can be used to program externally, but again, you can also use it for any other board, and for that there's also another solder jumper on the back.